All right, we're ready to start Unit 8. And with Unit 8, we're going to be talking about sequences, which we'll define in just a minute. But we're going to use a simplified approach so that the formulas are a little bit easier. So let's go ahead and get started with 8.1. The I can statement is I can understand and use arithmetic sequences. So we'll write the word sequences right here. And then let's take a look at the warm-up. It says, what does the italicized word mean in the context of these sentences? So the first sentence says, he could not get the lock undone until he put the numbers in the right sequence. So when we say sequence in this case, we're talking about putting things in order. So in order. And then the next one says she scored a goal in 4 consecutive games. So when we say consecutive, what we mean is in a row. Okay, so a sequence is just basically a list of numbers. So we'll write list right there. And it's usually produced by a formula, and they come in a particular order. So they come like one after the other. And a formal definition would be something like this. A sequence is a function whose domain is the set of consecutive integers starting at 1. So remember, integers are positive and negative whole numbers, including 0. So we basically start with 1, and we plug that into the function, and it produces the first one. Then we plug in a 2, and a 3, and a 4, and so forth. So each individual entry in the list is called a term. So we'll write the word term right here. And each term has a counter, and that counter has a fancy name. It's called an index. So when we talk about the index, we're talking about what we're plugging in or what the term that we're on. And the index is the number that you plug into the formula that gives you the value of the term, and it keeps track of which term you're on. So here are a couple of examples. So if we say A1, or we say A sub 1, because that's written subscript, notice how it's a little bit smaller and written down below. That represents the first term. And B9, or B sub 9, that represents the 9th term. Make that look like a 9. And then C sub 52, that would be the 52nd term. And then as weird as it sounds, if we say A sub n here, that represents the nth term. Sounds weird, but that's the way we say it. So we can use the index and a function to produce a sequence, and I'll show you a simple example right here. So I'm going to slide down. It says list the first 4 terms here in example 1, and example A says A sub n is equal to 2n plus 5. So you'll notice that this is what we call a general formula, and the index goes in both places. If we're going to plug a number in on this side, so say we plug in a 1 to get the first term, we're going to put a 1 right there. So I'm going to write out the first couple of terms. So this is going to be the first one, this is going to be the second one, the third one, and the fourth one. And when we write it out, we call that expanded form. So we've got a general formula right there and expanded form. We'll write the word expanded here. Expanded form. So in order to figure out the first term, we're going to put a 1 right here. So this is going to be A sub 1. If we put a 1 right here, where the n is, we're going to put a 1 right there. So this is going to be 2 times 1 plus 5. So 2 times 1 is 2 plus 5. This is going to be a 7. So the first term is going to be a 7. Then the next one, I'm going to do A sub 2 here. So this is going to be 2 times 2 plus 5. Again, I'm just putting a 2 right here in the index, and then I'm putting a 2 right here in the formula. So this is going to be 4. And 4 plus 5 is 9. And then the next one, I'm losing a little bit of space here, so this is going to be A sub 3. Again, we'll put a 3 in the index here and here, so we'll do 2 times 3 plus 5. That's going to be 6 plus 5, so we end up with 11. And then this last one, this is going to be 2 times, we'll put a 4 in where the index went, again right there, and then we're going to add 5, so this is going to be 8 plus 5, so we're going to end up with 13. So we end up with this nice easy pattern here, 7, 9, 13, 11, 13, and then you can kind of imagine that this is going on. They only asked us for 4 terms, so we're going to stop right there. So we'll do the next one right here. This is B, and notice that we've got A sub n here and B sub n. We can use any letter that we want. We usually use n for the index, though. So I'm going to write down B sub 1, and then we're going to do B sub 2, and then we're going to do B sub 3, and then we'll do B sub 4, and then we'll write them all down. So this is going to be negative 3 times 1. And then we're going to add 1. So this is going to be negative 3 plus 1. That's going to be negative 2. And then the next one's going to be negative 3 times. We're plugging in a 2. And then we're going to add 1. So this is going to be a negative 6 plus 1. That's going to be a negative 5. And then we've got negative 3 times 3 plus 1. That's going to be negative 9 plus 1. So that's going to be negative 8. And then this last one, negative 3 times 4 plus 1. that would be negative 12 plus 1, and negative 12 plus 1, that's going to be negative 11. So I'm just going to put a comma in between each of these. So up here we had the first 4 terms of this sequence. Now we've got the first 4 terms of this sequence. It is negative 2, negative 5, negative 8, and negative 11. And again, you can kind of see that there's a pattern here. Maybe not as easy as the last one, but there's definitely a pattern. Now, the nice thing about these formulas is that you can get any term you want by plugging in the index. So if we want the 51st term, plug in a 51. If you want the 97th term, plug in a 97. And these types of formulas go by several different names. We call them a general formula like we did up here. You can also call it an explicit formula, or you can call it an nth term formula. So these are not different formulas. These are just different names for the same idea. This idea that you've got this little formula, if you want the 51st term, you plug in a 51 or whatever it happens to be. Now, there's another type of formula that will produce a sequence, and it's called a recursive formula. So a recursive formula. Make sure I spell this right. Recursive. A recursive formula. Now, the word recursive, kind of sounds like reoccur, and that's what's going to happen is terms are going to come up again and again. So they can be really useful. They're not as nice to work with as nth term formulas, but they are some nice places where we can use them. So a recursive formula uses previous terms to define the terms that follow them. And because of this, a recursive formula has to give you 2 things. It has to give you a first term, so we'll write first term. Gives us a place to start, and it's got to give us a formula. So we'll write formula right here. It's got to give us a formula to get from any term that you know to the next term in the sequence. So it's going to go from a term that you know to just the next term, and those are the type that we're going to start with here. So example number 2, it says list 4 terms given by the sequence that's defined as, and now this is a recursive definition. You'll see they're a little tougher to work with. A sub 1, again, that's the first term, and we don't always get the 1 there, but if it's written there, great. If it's not, we assume that it's a 1. So this is going to be the first term is 7. And then this is the recursion formula. Notice that it looks a little bit nasty here. So we've got a sub n over here. So notice that the index is right here. And then we've got a sub n minus 1. So these are both written smaller and a little bit lower. They're subscript, we say. So I plug in the same number here and here, and then I'm going to take whatever that term is right here, and I'm going to add 2 to it. So let me show you how this works. If I want the first term, so I'm just going to write down a sub 1. Well, the first term is 7, and I've got that. We're done with that one, so I'm going to go ahead and put a little circle around that. If I want the second one, so I'm going to do an a sub 2. Well, notice in this formula, this is the recursion formula, it says if I want the second one, so a sub 2 would equal, well, I'm going to do the same thing over here. I'm going to do 2 minus 1, because that's the little formula in the index, and then I'm going to add 2. Well, that would be 2 minus 1, so this means a sub 2 is going to be 2 minus 1, so that's a sub 1, and then I'm going to add 2. Well, this means that the second term, in order to find that, we've got to know the first term, and then we've got to add 2 to it. So the first term was over here. That's going to be 7 plus 2, so we end up with 9. So I'm going to put a little dotted circle around this one right here. The second term is 9. Now, it said write out the first 4 terms, so I'm going to find the third one. So the third one is going to be, we're going to write down, again, the index goes here, and it goes over here. So this is going to be 3 minus 1, and then we're going to add 2. And again, notice how I've written these both a little bit smaller and subscript, and this 2 is still the same size as the a. It's kind of on the same line if you want to think of it that way. So this is going to be a sub 3 equals a sub, well, let's see, 3 minus 2, 3 minus 1, well, that would be 2, and then I'm going to add 2. So to find the third term, I take the 1 right before it, I take the second term, and then I add 2 to it. So this is going to be, we had a 9 right here, plus 2, so this one's going to be 11. So the terms go like this. I've got a 7, a 9, and an 11. Now I want the fourth one. So for the fourth one, again, the recursion formula works like this. This is going to be a sub, well, if this is 4, look what happens. This is n minus 1. This is always going to be 1 less than that. So this is going to be the third one, and then we add 2. It didn't ask for this, but if we wanted to find the fifth one, we'd use the fourth one, and then we'd just add 2 to it. So basically the formula for this recursive sequence just says, hey, take the last one and add 2 to it. So the fourth one is just going to be the third one, which is 11 plus 2, and we end up with 13. So I'm going to go ahead and take each one of those circled ones here, and I'm going to write it in a nice little fashion here. So here's my list of numbers. Here's my sequence: 7, then 9, then 11, and then 13. And I'll just put a box around that right there, and we'll be done with that one. Okay, so there's one recursively defined sequence. So let's do another one here really quickly. It says list the first 4 terms given by a sub 1 equals 10, and then a sub n equals a sub n minus 1. And again, the way to think of this is if we're on the nth one, the n minus 1, this is the one right before it. So this is the next one, and this is the previous one. So we'll write previous here, previous one. Okay, so the first one in this case, so this is going to be a sub 1, is 10. So we've got that one taken care of, all done there. Now, if we want to find the second one, here's what the formula says. The formula says if you want the second one, if you want the nth one, take the one right before it. So that's going to be the first one, and then we're going to subtract 5. So the first one is 10, so 10 minus 5, that's going to be 5. So a sub 2 is 5. So we'll put a little circle around that one. We've got those two. Now you'll notice we're getting a little bit quicker at this. So let's find the third one. So if I want to find the third one, that's going to be, again, if I'm on the third one, this is going to be the one before it. That's what the formula says. The n minus 1 would be a sub 2. Whoops, and then we're going to subtract 5. Sorry about that. We'll put a minus 5 right here. So this is going to be the third one is equal to the second one, 5 minus 5. So this means the third one is just 0. So we've got 3 of them, and now we just want to find the last one. So let's find a sub 4. So remember, this is the fourth one. So again, we say a sub 4. What we're really talking about is just the fourth one if we talk like normal people. So the fourth one is going to be the one before it. So that's going to be a sub 3, and then we're going to subtract 5. So this is going to be 0 minus 5. So that means the fourth one is, let's see, 0 minus 5, so we get negative 5. So there are the 4 terms. So I'm just going to write down a 10, a 5, a 0, and a negative 5. And that's going to be our sequence. So those are the first 4 terms of the sequence defined by this one right here. Now, understanding that notation, the recursive definition, this little formula that, hey, we use the previous one, I mean, all these really weird things floating around here, it really stretches your brain, okay? This is really good brain stretching activity. And again, like I said a minute ago, sometimes they'll put the 1 here, occasionally they won't. If they don't, they still mean the first one. It's kind of like if we say x, what's the coefficient in front? It would be a 1. So you'll notice that recursive formulas, they are a bit of a hassle because we have to get all of the terms in order, so we'll write the word order right here, until we get to the one that we want. So if you wanted the 50th term, you would have to get the other 49 terms first. You'd have to get terms 1 through 49 before you could get to that 50th one, because you've got to use the 49th one in order to make the 50th one. So here's what we've got so far. We've just covered there are 2 different types of formulas. There's a general formula and there's a recursive formula. And now we're going to look at a special type of sequence with a special name. So you may have noticed something about all of the sequences so far. The numbers are either getting bigger or they're getting smaller by exactly the same amount every single time. So each time we add the same number, even if it's negative, so if it's negative it would actually make them smaller, okay, in order to get the next term. So since the difference between every pair of terms is the same every single time, we call this a common difference. Okay, so we'll write the word common right there. And then this type of sequence where it goes up by the same amount every single time or goes down by the same amount every single time, we call this an arithmetic sequence. So we'll write the word arithmetic. Okay, and arithmetic in this case, it's pronounced a little bit funny because it's an adjective rather than a noun. Just a little English there for you. So let's see if we can figure this out by looking at an example here. So I've got a couple of questions that'll help, and then I've got this sequence right here. So you'll notice I've got 4, 7, 10, 13. So this is the first one, this is the second one, this is the third one, and this is the fourth one, and so forth. We could keep going. It's got that little dot, dot, dot there. And it says, what is the difference between A1 and A2? 2. So in other words, we're going from 4 to 7. So what is the difference? It means how far is it from 4 to 7? Well, the way we do this is we're going to take 7 and we're going to subtract 4, because what that gives us is that gives us positive 3. And we went up by 3, so we need that difference to be positive. And then it says, what's the difference between A2 and A3? Well, between A2 and A3, again, we're going to kind of reverse the order. We're going to do 10 minus 7, and we get 3 again. So you'll notice that what's happening here is I'm adding 3, adding 3, adding 3 every single time. So that's what we call the common difference. Now, if you want to find the common difference on an arithmetic sequence, don't forget, we can always find that by taking any term that you want and subtracting. So take any term you want and subtract the one before it. So if I want to find the common difference, I take the second one, subtract the first one, third one, subtract the second one, fourth one, subtract the third one. If I had a fifth one, I could subtract the fourth one, and that would tell me the common difference. It's got to be the same all the time because, again, we're talking common. Got to have that common difference. Now, we might guess that the formula on this one is 3n. So the nth one is 3 times n. But what happens if we plug a 1 into this to figure out what the first term is? Well, if we do that, a sub 1 would be, well, I'd plug in a 1 right here, and I'd plug in a 1 right there. So that would be 3 times 1, and we end up with a sub 1 equals 3. Well, what it's supposed to be is it's supposed to be a 4, and what we've got is a 3. So it's not quite there. This is not going to work for the formula of an arithmetic sequence because it doesn't start in the right place. So we're going to make one tiny little adjustment to it by adding what we call an initial value. So write the word initial. The initial value. Now, the way we say this is we say a sub 0, or if we're British or we get really fancy, then we say a naught, because naught is another word for 0, kind of like it was all for naught, it was all for nothing. Okay, so in this particular case, so for the example up above, we're going to say that a naught is equal to 1. So you can think of this like the 0th term. So it's not a mystery how we got it. It's the 0th term, so it's basically like saying, what would the initial term of the sequence be when we haven't added any common differences? So if I were to go backwards a little bit in this formula, so what would a sub 0 be? So if I could go backwards, instead of adding 3 every single time, I'd subtract 3 in order to get back to this one right here. So we'd say 4 minus 3 would be 1. So that's going to be the 0th term. I'm going to make that look a little bit better right there. Okay? So for this one, for the example in number 4, it's a sub n equals 3n, and then we just make this little adjustment with the initial term. Okay? So again, hopefully you can see from the numbers up above how we can kind of back up and find that 0th term because the pattern just goes backwards. So I'm going to slide down here and we're going to talk about a couple of different formulas. So remember, we're dealing with all arithmetic sequences today, and we have 2 different types of formulas. We've got a general formula and an recursive formula for these arithmetic sequences. Now, here's what it looks like. So the a sub n, that's going to be the nth term. I'll just write that down here. Okay, is going to be the common difference times n. So remember the d, whenever you see that when we're working with these sequences, that means common differences. So this is common difference. Okay, and this a naught here, that is the initial value. You could also say that that's the initial term. Okay, I'll just put term in parentheses. Okay, that's where it all began. Now, the cool thing about this is there's a great way, I mean, since we know that everything is arithmetic, we can always find the difference. Just take the second term and subtract the first term. So if you kind of just remember, hey, I'm always going to take the first terms and I'm going to subtract the first one from the second one. And then we also just reverse that pattern. So if you want to find a naught, we always take the first one and then we just subtract whatever the common difference is, so we can go backwards just a little bit. And that makes the recursive ones pretty easy. So a sub 1, again, is the first term. Okay, it's not a sub 0, it's not a naught, it's the first term. Again, unless we're told otherwise, we always start by plugging in a 1 for the sequence, or for the index. Okay, and a sub n, that's the next term, and a sub n minus 1, that's the one right before it, so we'll call that the previous term, and then we're just going to add the common difference. And we just want to make these look as nice as we possibly can. So I'm going to slide down here. I'm going to leave enough of this showing that we can write these down. So you'll notice that we need to do 2 things. We need to find a general formula formula, and we need to find a recursive formula for each one of these. So I'll show you that this really isn't too bad. So let's do the general one first. So the general one looks like this. So it's going to be a sub n is equal to the common difference. Well, the cool thing on this one is they told us what the common difference is. They said it's negative 11. So I'm going to write down negative 11, and then we multiply that by n. But I need to figure out what the initial value is. I need to figure out the first one. So there's a couple different ways that I can do that. Sometimes it's helpful to write out the first couple of terms. So you'll notice that the first one on this one is 10. And then we're going to subtract 11. So if I subtract 11, 10 minus 11 would be negative 1. And then I'm going to subtract 11 again, so I'm going to get negative 12. Then I'm going to subtract 11 again, I'm going to get negative 23, and so forth. That would keep going. So if this is the first one, I can back up one term, and I can get the 0th one. Well, going this way, we're subtracting 11 every single time. So going the other way, I'm going to add 11, and I end up with 21. Now let's make sure that this fits the pattern. 21 minus 11 is 10. 10 minus 11 is negative 1. Negative 1 minus 11 is negative 12, and so forth. So that makes this the initial term, so we're going to write down a 21. Again, if you wanted to use this little formula right here, we could do a naught is equal to the first one, which is 10, minus 11. So take a look at that. Minus 11, that's going to be plus 11, so we're going to end up with 21 out of that. Okay, so there's the formula. There's the general formula, and now we're going to find the recursive one. And the recursive one, remember, you always have to tell it where to start, so we've got to start at a sub 1. So a sub 1 is, they said it was 10, and then we just have to tell it how to get from the previous one to the next one. So I like saying the next one, so I'm going to write down a sub n is the one right before it, so that's a sub n minus 1, that's the previous one, plus the common difference. Now in this case, the common difference is negative 11, so if you want to write plus a negative 11, that's totally fine. If you want to just write a negative 11, which is what I'm going to do, that's okay. The thing you want to be careful with is notice how I've got these indices written down here. They're clearly below this, and then I've got the 11 kind of large. So this is the recursive formula, okay? So on the next one, let's take a look at this. It says b equals 2. Now remember, if there's nothing written there, that's going to be the first one, and then the common difference is 5. So that means we start off with a 2, and then we're going to add 5, plus 5. So this is going to be a 7, this is going to be a 12, this is going to be a 17, and then we could just continue that way. So the formula, the general formula, the nth term formula, explicit, whatever you want to call, is going to be b sub n. We're going to take the common difference of 5, we're going to multiply it by n, and then we're going to add the 0th term. So we can find that two ways. I'm going to use the formula first right here. So I'm going to do b sub 0, or b naught, is equal to the first one minus the common difference. So that's going to be 2 minus 5. That's going to end up being a negative 3. So I'm going to add a negative 3, okay, which is going to turn into just a minus 3. So I'm just going to write b sub n is equal to, and I'll put that around parentheses around that. So that's going to be 5n minus 3. So I'm going to go ahead and circle this right here. There's the nth term formula. And again, if I wanted to, I don't really have to go through these fancy arithmetic calculations. If I write out a couple of terms and I get a sense of what it looks like, to go this way, we're adding 5 every single time in between each set of terms. To go the other way, I would subtract 5. So if I subtracted 5 from 2, I'd end up at negative 3, and that would be the 0th term, and that's the one that I plug in right here. Okay, let's write down the recursive definition here. So we have to give it a place to start. So the first one, again, is 2, and then we say, hey, if I need to get to the next one, I have to take the one right before it. So that's b sub n minus 1, and then I'm going to add whatever the common difference is. In this case, the common difference is 5, so I circle that, and we're all set. Okay? All right, to finish this off, we're going to take a look at a couple more examples. So we want to find a general and recursive formula for each one of these, and you'll notice that we have them all written out. We've got 4, 7, 10, 13, so it's pretty easy to tell what the common difference is. The common difference on this one is positive 3. So we've got the common difference. What we need is we need the initial term. We need this a naught. So let's just go backwards 3. So instead of going forward 3 by adding 3 every single time, we're going to go backwards 3, and that's going to put us at a 1. So this is going to be a sub n is equal to, it's going to be the difference times n. So that's going to be the common difference times n, and then we're going to add 1. Now you'll notice that this should look very similar, or familiar. It's the one on the other side. We just had it, or the one at the top of the page, we just had it kind of written out for us, and we were asked to come up with a formula, so we're all set to go. Got that again. And then we're going to write down the recursive formula, so that's going to be a sub 1. The first one is 4. Remember, that one right there, the 0th term, we only use that for the general formula. So that's the first one, and to get to the next one, we use the one right before it, which would be a sub n minus 1, and then we add the common difference, and in this case the common difference is 3, so there we go. Okay? Now this last one, I'm going to try and do this really quickly. You'll notice that we go from 55 to 49 to 43 to 37. Let's see, if we went from 55 to 49, we're going down, so that means the common difference is going to be negative. And we went from 55 down to 49, so that's going to be negative 6. So immediately what we can write down is we can write down b sub n equals negative 6n. And then all we need to do is we just need to find what's that 0th term, what's that initial term. So in order to find that, we're just going to go, instead of subtracting 6 every single time to go from one to the next, to go the other way, we're going to add 6. So let's add 6 to that, and we end up with 61. So that 0th term, if you will, that's going to be a 61. So I put a 61 right here. There's the nth term formula, and then I just write down the recursive one. The first one in this case happens to be 55. Again, don't grab the 61 there. And then we're going to say, hey, if you want to get to the next one, you take the one right before it. So that's b sub n minus 1. And then we're going to add the common difference. Now, if you're thinking ahead and you say, hey, wait a minute, this is a negative 6. That looks kind of silly. We can definitely put this right here and just say that's going to be a negative 6. Now, my b's and 6's look kind of the same, so I apologize for that. But that right there would be the recursive formula. So we're talking about arithmetic sequences on this assignment, and we're talking about two different formulas. One's the general formula, and the other one is the recursive formula. Now, if we were asked to find the indicated term for the sequences up above, which would you want to use? If you had to find the 102nd term, would you want to use the general formula, or would you want to use the recursive formula? Well, I think we'd all definitely want to use the general formula here, because we can just plug in a 102. We don't have to find the first 101 terms like we would with a recursive one. So we're going to use this formula. So this is going to be 3 times 102. Whoops, I'm going to change colors here. So we're going to do 3 times 102, and then we're going to add 1. 3 times 102, that would be 306 plus 1. So we end up with 307 would be our answer here. All right, and if we want to find the 35th term, we're going to take b sub 35, because that's what this means. It means the 35th term. And we're going to do negative 6 times 35, and then we're going to add 61. If we throw that into a calculator really quickly, so let me clear this off, and we're going to do negative 6 times 35, and then we're going to, add 61. And we end up with negative 149. So the answer on this one is negative 149. So we'll go ahead and circle that. Now, the last one is kind of interesting. It says, complete the statement for the arithmetic sequence. So we know we've got an arithmetic sequence. It says negative 203 is the blank term of 55, 49, 43, 47. So the cool part about this is we should recognize that it's this sequence right here. Okay, so again, starting with 55. So the formula is right here. So we're going to write b sub n, whoops, got to get rid of that. So b sub n is equal to, negative 6n plus 61. So again, this is the sequence. We're going to use this formula right here. Now, what they've told us is we've got negative 203, and they want to know what the nth term is, or which term that is. So they haven't told us the index. Normally we get the index and we plug it in, but it's the opposite on this one. They give us this term and they want us to find the index. So we're going to do negative 203 equals negative 6n and then plus 61. So I'm going to subtract 61. So I'll get a negative 6n equals, let's see, that would be negative 264. And if I wanted to get the n by itself, I'm going to divide by 6 on both sides. So we'll just divide by 6 here. And the good thing about this is n turns out to be positive, and if you throw that into a calculator, if we do negative 264 and we divide that by negative 6, we end up with a positive 44. Now, if we say n equals 44, just like here when we said n equals 35, what that means is this must be the 44th term, okay? All right, so go ahead and circle how you feel about this right now, and good luck on the assignment.